In this video, we discuss finding the sum of a finite arithmetic sequence. Now, we already know a little bit about finding sums, and as you guys have seen, it can become a bit tedious when we have large number of terms in our series. Writing out all the terms and adding them together just isn't that much fun. Fortunately, when we are dealing with an arithmetic sequence, a sequence in which we have a common difference between our terms, there is a formula that is going to help us out. The sum of a finite arithmetic sequence with n terms is given by the formula S subscript n is equal to n divided by 2 times the quantity a1 plus an, where n is the number of terms in the sum, a1 is the first term in the sum, and a subscript n is the last term in the sum, right? And we can use this formula to help us in finding the sum of any finite arithmetic sequence. Okay, so the key thing is the sequence must be finite, meaning we have a set number of terms we are adding together, and this formula only applies to arithmetic sequences, meaning that the terms are going to have a common difference or a linear relationship. For example, find the indicated nth partial sum of the arithmetic sequence. Here we have the sequence 2, 8, 14, 20, 26, comma, dot, 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 comma, and we want to find the 100th partial sum. That means we want to add up the first 100 terms of this sequence. Well, in order to use our formula here, one, we must know n, which is the number of terms, and that's actually given to us. All right, we must know a1, which is going to be the first term in the sum, and the first term in this particular sum is going to be 2, right? That's the first term that we are going to be adding together. And we must also know an, that is the last term in the sum. Well, we don't have the last term in the sum in this particular case, right? But we are going to have to find it. We must find the 100th term of the sequence. Well, as you guys have seen before, if we want to find any of the particular terms of the sequence, the easiest way to do that is to come up with the expression for the nth term. Now, because this is an arithmetic sequence, the nth term of our sequence will have the form a subscript n equals dn plus c. Again, notice the linear relationship, y equals mx plus b. Very similar. Okay, so in order to come up with our equation for the nth term, we have to know d, our common difference, and we have to know c. D, the common difference, can be found by taking one term and subtracting the previous term. 8 minus 2, or 14 minus 8, or 20 minus 14, or 26 minus 20. All of those give us our common difference D, which is equal to 6. We must also find C. Now recall that C corresponds to what would be the y-intercept of our sequence, or the 0th term. Well, we know that the first term is 2. Our common difference is 6, meaning that I add 6 to go to each consecutive term. Well, if I wanted to find the 0th term, or the term that would come before 2, all I have to do is take 2 and subtract my common difference, 6. C is equal to 2 minus 6, which is equal to negative 4. All right, so negative 4 would be the term that comes before 2 if there were a 0th term. Again, that corresponds to the y-intercept, or the 0th term of our sequence. So now that we have D and we have C, we can plug those into the formula to give us our expression. A subscript n is equal to 6n minus 4. This equation right here will give us the nth term of our sequence. Well, we want to find the 100th term, a subscript 100. So that means we plug in 100 for n. That gives me 6 times 100 minus 4. 600 minus 4 gives me 596. Now that I have n, the number of terms, I have the first term, and I have the last term in the sum, all we have to do is plug them into the formula. S subscript 100, this is the sum of 100 terms, is equal to 100 divided by 2 times 2 plus 596. And plugging that into our calculator, we are left with 29,900. Let's look at a few more examples. Find the partial sum using the proper sum formula. Verify your solution using a calculator. Okay, so we need to make sure we're using the correct sum formula. So far, we've only talked about this one sum formula, but as we continue in the chapter, there's going to be a couple more that you will be familiar with. So in order to pick the correct one, we must be able to identify the type of sequence we are dealing with. Well, this is an arithmetic sequence. Okay, note that this is a linear format. We have a subscript n equals d times n plus c. But in this particular case, all right, our c is just written first, and d, the coefficient in front of the I, or the slope of this linear sequence, is -1. So yes, this does have a linear format. All right, our consecutive terms would have a common difference. Therefore, we can use our sum formula for a finite arithmetic sequence. S subscript n equals n over 2 times a1 plus an. Well, in order to use this formula, we have to know n. Again, n represents the number of terms in the sum. How many terms are we adding together? Well, we're starting this sum with I equals 1, and we are going up to 250. That means if I start by plugging in 1 to get the first term, 2 to get the next term, 3 to get the next term, so on and so forth, until I plug in 250 to get the last term of the sum. That would give me a total of 250 terms that we are adding together. So n is equal to 250. Again, the number of terms in the sum. Next, a1. a1 is the first term in the sum. Well, this sum begins at I equals 1. To find the first term in the sum, we would plug in 1 for I, giving us 1000 minus 1, which is 999. And finally, we need to know the last term in the sum. What do we get for the 250th term of the sum? Well, the last term, we would plug in 250. That would be 1000 minus 250 gives me 750 for the last term in the sum. Now that we have all this information, all we have to do is plug it into the formula. S sub 250 is equal to 250 divided by 2, times the quantity 999 plus 750. We plug that into our calculator and hit enter, and we get 218,625 as our answer. Now, we can also verify this solution by plugging this sum directly into our TI-84. Remember that your calculator can compute summation notation by hitting math and then selecting 0, math and then the number 0. That will bring you up our sigma notation, and you can plug it in directly as you see here. Hit enter, and yes, it will spit out the exact same value. All right, so our sum formula, it doesn't lie. All right, let's try a couple more. Find the partial sum using the proper sum formula. Verify your solution using a calculator. Here we have the sum from n equals 17 to 93 of 2/3 n plus 2. Now again, what type of series are we dealing with? Well, we notice here that we have a linear relationship between the terms. Notice a subscript n equals d times n plus c, right? If we have a linear relationship, that means the sequence is arithmetic, and we can use our sum formula for a finite arithmetic sequence. So, in this case, we have to, again, determine n, a1, and a subscript n. N represents the number of terms in the sum. Now, this one's a little bit tricky because notice that the lower limit of the summation is not 1. All right? Anytime the lower limit of the summation is not 1, we can find the number of terms in the sum by taking the upper limit, subtracting the lower limit, and adding 1. That will give us the number of terms. In other words, we take 93 minus 17, and we add 1 in this case. All right? Doing so leaves us with 77. So there are going to be a total of 77 terms in this series. We would be adding up a total of 77 terms. Now, if you're wondering, 93 minus 17, that gives me the difference. And then I have to add 1 because we actually start by plugging in 17. So to account for plugging in 17, we add 1 to that value. All right. So we have n. N is equal to 17. Now we have to determine a1. Now again, A1 is the first term in the sum. Read that very carefully. The first term in the sum. And this summation actually begins with n equals 17. So to find the first term in the sum, we are going to plug in 17. That's 2/3 times 17 plus 2. We plug that into our calculator, hit enter, hit the math frac button. Always nice to get a nice easy fraction to work with if we can. And we end up with 40 divided by 3. There is the first term in the sum A1. And A subscript 77 would be the last term in the sum, right? We're trying to find the sum of 77 terms. A77 is going to be the last term. So how do we find the last term in this sum? Well, to find the last term, we need to plug in 93. We plug in 93 because that's the upper limit of the sum. The last term would be 2/3 times 93 plus 2. We plug that into our calculator and we get 64. And now that we have the last term, the first term, and the number of terms that we are adding together, we plug them into the formula. S subscript 77 is equal to 77 over 2 times the quantity 40 over 3 plus 64. We hit enter and we get 2,977.33 repeating. Now, depending upon your calculator, if you've got a newer TI-84, you might be able to math frac this guy and get a nice fraction to work with, right? But this repeated decimal is sufficient. All right, let's try one more. A word problem in this case. A landscape architect is designing a brick patio that has the approximate shape of a trapezoid. The patio consists of 100 rows of bricks. The first row has 14 bricks, the second row has 16 bricks, the third row has 18 bricks, and so on. How many bricks are in the patio? Okay, a couple things to recognize here. One, the number of bricks in each row follows an arithmetic pattern, right? The first row is 14, 16, then 18. The next one would be 20, then 22, so on and so forth, okay? Secondly, because we want to add the number of bricks in each row, we are calculating an arithmetic sum, right? We're taking this list of numbers and we are adding all of the terms together. Because we are calculating an arithmetic sum, we want to use our sum formula for the sum of a finite arithmetic sequence. Again, S sub n is equal to n over 2 times a1 plus an. Well, if we're going to use this formula, we have to know n, the number of terms in the sum. How many terms are we adding together? Well, our patio consists of 100 rows. These are the amount of bricks in each row. Therefore, we are going to be adding 100 numbers together. N is going to equal 100. A1 is the first term in the sum. Well, notice that our first row contains 14 bricks. That's going to be the first number that we are adding. A1 is equal to 14. And in order to complete the formula, we must know the last term in the sum. That's represented by the number of bricks in the last row, or A subscript 100. Well, how are we going to find how many bricks are in the last row? Let's come up with an expression that gives us the number of bricks in each row. And because we have this linear progression of our terms, we know that it is an arithmetic sequence, which can be represented by A subscript n equals dn plus c. We can come up with an equation that gives us the number of bricks in each row. To do so, we have to know what d is, our common difference. We can find d, our common difference, by taking any term and subtracting the previous term. 16 minus 14, or 18 minus 16, or 20 minus 18, or 22 minus 20. All of those give us a common difference. D is equal to 2. To complete the equation here, we also need to know what c is. C corresponds to the 0th term, or the term that comes before my first term. Well, if 14 is the first term, and as I go to the right, I have to add 2 each time, all that means is to get the 0th term, I would simply subtract 2. 14 minus my common difference of 2 gives me c is equal to 12. And now we have our expression a subscript n is equal to 2n plus 12. This equation right here will give us the number of bricks in each row, in the nth row. Notice if I plug in 1 for n, I get out 14. If I plug in 2 for n, I get out 16. If I plug in 3 for n, I get out 18, right? The third row has 18 bricks. If I plug in 4 for n, I get out 20, so on and so forth, all right? So now we want to find how many bricks are in the 100th row. Well, that means I need to plug in 100 for n. Plugging in 100 for n gives me 200 plus 12. A subscript 100 is equal to 212. So now we have all the values to plug into our sum formula. S sub 100 is equal to 100 divided by 2, that's n over 2, times the quantity, a subscript 1, that's the first term, which is 14, plus the last term in our series, which is 212. All right, 100 over 2 times the quantity 14 plus 212 gives us a final answer of 11,300 bricks.